This time, we'll be discussing the answers to our mock test, and maybe I will be partitioning the mock test in around 2 to 3 parts so that the video won't be too long. Okay, so let's start first with the true or false. So we have here negative perfect number, sorry, negative perfect cube numbers have a negative cube root. So what does it mean? What does it mean? So let's say, for example, we have negative, let's say negative 8, and you get the square root of that, the cube root of that one, cube root of negative 8. So what's our answer here? Our answer is going to be negative 2. Let's say we get the cube root of negative 27. The answer here is negative 3. So this question actually is supposedly true. Okay. I mean, this sentence is true because, okay, the cube root of negative 8 is negative 2. Cube root of negative 27 is negative 3. So to further explain this one, this actually came from negative 2 times negative 2 times negative 2 is actually negative 8. Because again, we have here 1, 2, 3, 3 negative signs, and that's an odd number. And our rule is that when there is an odd number of negative sign, the result or the product is going to be negative. So same thing with this one. The answer to the cube root of negative 27 is negative 3 because negative 3 times negative 3 times negative 3 is negative 27. Again, 3 times 3 times 3 is 27. And we have here 1, 2, 3. 3 negative signs, and that is an odd number. That's why the result here is going to be negative 27. And that's why, so the statement, negative perfect cube numbers have negative cube root, is actually true. Okay, we will proceed. Now, so let's analyze this question. So all irrational numbers, sorry, this one should be all irrational numbers are real numbers. So where's irrational number here? This one, right? And obviously, irrational numbers is just inside our real number. That's the simplest explanation we can have here. And that's why this question is actually true. Okay, let's proceed to the third question. So all numbers, or sorry, all whole numbers are rational numbers. Where is whole number? Whole number is here, right? Here's the whole number inside our rational. Rational number, it covers the big red circle here. And again, what does it mean? Whole number is just inside the rational number. That's why it means to say that everything or all the whole numbers are actually rational. And that's why this one is true. Let's proceed. All integers are irrational numbers. Where's our integer? Here. So it's like this blue circle here. I mean the purple circle here. This one. So here's our integer, and then the irrational numbers are here. They never coincide. They never relate with each other. That's why integers can never be a rational number. They never intersect, and integers are never part of a rational number. Integer is part of rational number. That's why this one here is false. Next one. Some integers are irrational numbers. Where's our integer? Here again, right? So some of these integers are irrational. Again, that can never happen because they never coincide. So integers is here, irrationals are here, different circle, different group, they can never intersect. So integers can never be irrational number. So this statement here is false. Next one, number 6. So all numbers you raise to 1 are equal to the number itself. Well, this one is actually true. Even you raise 0 with 1, that's still 0. And then 1 raised to 1, that's still 1. 2 raised to 2, I'm so sorry. 2 raised to 1, that's still 2. 3 raised to 1, that's still 3. Nothing happens. It's just really the number itself. Okay? Next one. All numbers you raise to 0 are equal to 1. All numbers you raise to 0 are equal to 1. Let's check. So, actually, this one is almost true, right? Because let's say, for example, we have 3 raised to 0, that's 1. 4 raised to 0, that's 1. 100 raised to 0, that's still 1. However, this one is false because this should have an exemption. It should write except 0 because 0 raised to 0 is not equal to 1. Okay? Please remember that one. Actually, this is called indeterminate. However, this one is not yet our concern for the meantime. Again, this one is false because it should put except 0. Okay? Not all numbers raised to 0 is equal to 1 because there is an exemption and that is 0. Next one. Number 8. There are 5 quadrants on the Cartesian plane. I guess this question is kind of obvious, right? So once we have our Cartesian plane, we have here quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Please make sure that you're familiar with the positioning of the quadrants. Again, you only have 1, 2, 3, 4. You only have 4 quadrants, not 5. That's why this one here is false. Okay? Next one, number 9. We can find the point of origin at the point 1 comma 1. Okay? I guess there's no need for me to further explain this one. But again, this one is false because, okay, just please take note that the point of origin is our center, right? So when we have here our y-axis, our x-axis, this is our point of origin. The one at the most center, that's the point of origin. And that coordinate at that point is actually 0 comma 0. Okay? Next one. In calculating the slope, we divide the run by rise. Okay? This one, I will tell you right away, this one is false. Because I guess there's no need to further explain this. I'll just tell you the correct statement. So, we should actually divide, not run by rise, but it should be the opposite or the other way around. So, slope is actually equal to rise over run. Please take note of that. This rise here pertains rise, right? Going up. So, that's our y. And then this run is like you go with left or right, right? I'm keep on repeating the word right. I'm so sorry. So, the run here is our x. So same thing with our unit rate wherein you divide the y by x. However, again, going back with the formula for slope, this is rise over run. Okay, that's why this one is false. Okay, 11. In calculating the slope, we divide the change in y by change in x. It's like you divide the change in y by the change in x. That's our slope. And actually, this one is true. Let's proceed. Number I guess there's no need to further explain this one, because this one is just like you being familiar or having that knowledge of what is the formula for the slope, and that is change in y over change in x. Number 12, we need more than more than 2 points to calculate the slope of a line. Actually, I keep on repeating this one during class that we actually need at least actually need just 2 points, right? To find our slope. We just need two, not more than two. Okay? And actually when we have this exemption, right? That at some point when we have proportional relationship, Actually, we just need 1 point, right? Because, okay, please take note that all the time, I mean, in general, we need 2 points to find the slope. However, if the relationship is proportional, we just only need 1 point. So it's like you need one or two. However, it says more than two, and that's definitely wrong. That's why this one is false. Okay, we'll proceed. 13. The constant rate of change and slope are just the same. Well, again, this one is kind of trivial, right? Because it's just like you just have to be very familiar with these terms. And actually, this one is true. So it's true because the constant rate of change is really the slope. So it's like when the rate of change is the same all throughout, that's also our slope. Okay, we'll proceed. Number 14. So the equation y equals 7x is proportional relationship. Well, this one is actually true. So how do you know that relationship is actually proportional? We have this form, right? That y equals kx. Once the equation is following this form, it's automatically going to be proportional. So what if we have like y equals 7x plus 2? So this one is not proportional because we have this the plus 2. Okay? Again, always it should be like only y equals 7x, y equals x, y equals 2x. So these things here are the examples of proportional relationship and not this one. Let's proceed. This is the last question in the true or false. So the graph of proportional relationship always passes through the point of origin. Okay? This one here is actually true. So take note of this. Again, it always passes through the point 0, comma 0. It's like when you graph a proportional relationship, what happened? When you graph a proportional relationship, it should passes this line here, this point here, there. Okay? It should passes this point here. That's what it meant by the given statement. And I hope this one is clear for the first part, and this is for the true or false.